All right, is it time? I think there's still people coming in. Just come on in. There's still room for everyone. But thank you all for coming. My name is Mark Seemann, and if you want to know more about me, there's information there on blog.plur.dk, and you can follow me on Twitter if you're interested in figuring out what I have to say. So what I'm going to do today is that I'm going to try to answer a couple of frequently asked questions, and I'm going to answer two different frequently asked questions. And it turns out, at first glance, if you see both of those questions, side by side, it's not entirely clear, why they're related, but it turns out that they are. But what I'm going to do here, I'm going to give the talk in three parts. So in the first act of this three-part talk, I'm going to talk about the first frequently asked question and sort of try to explain why it makes sense to ask that question. But then I'm not going to answer the question because we need to learn some more stuff before we can actually, sensibly answer that question. So in part two, I'm going to put aside the first question for a while and then look at a different question. And then we go all the way through and try to figure out how to address that question. And then in part three, we've learned enough so that we can come back to the first question from part one and answer that in a satisfactory manner. So that's the plan. So three acts of the talk, if you will. So the first frequently asked question that I'll try to address here is, how do I combine dependency injection with async and await? And that seems easy enough, but then with a little extra qualification here, without leaky abstractions. And in order to explain, why this even is interesting to talk about, we'll need to look at some code examples in order to figure out, okay, what do I even mean by this? So whenever I want to show you code examples, one of my favorite scenarios is that you have to imagine that you want to develop an online restaurant reservation system. This is sort of my favorite scenario. I know all of these services already exist out there, but we can just pretend that the world needs another one of those. So it's one of those things where you want to make a reservation at a restaurant, so you fill in a form on the website or whatever, and once you filled in all your details, you press the submit button, and the UI creates a little JSON document, and that JSON document gets HTTP posted against a web server somewhere. And the code that we're going to look at is the server-side code that handles that incoming request for a reservation. So we'll start at the domain model, and at the domain model, the central decision is embodied in a method that looks like this. So it's called try accept. And it takes a reservation as input. So the reservation is just that JSON document, or the data from that JSON document, the dates, the quantity, the name, the email address. And the return value is a nullable int. So what does that mean? Well, if it's an int, that's a reservation ID. And if you have a reservation ID, that means you have a reservation. You can use that reservation ID to cancel your reservation or make changes to it or whatever. So that means you have a reservation. If you don't have an ID, if that's null, it means you don't have a reservation. So that's pretty obvious, I suppose. So there are reasons why sometimes we can't accept a request for a reservation, and we'll look at that in a moment. Now, if we're using dependency injection, we could inject various different dependencies on a class that has a method like this. So for example, we could inject a repository and just make it available as a read-only property like this. You notice that I'm showing you members of classes, and I'll show you some implementation code in a moment for the try accept method, but I'm not showing you the surrounding class, and that's basically just because I don't have space for that. Also, I'm not showing you the constructor that receives that repository and saves in that property for later use. It's 2019, and I somehow naively expect that people understand how constructor injection looks now in 2019. So I'm not showing you that. But if we have a repository like this, we can query it. So we can say, give me all the reservations for that reservation date. And that's just some reservations, and we can do a sum over all the quantities, and that gives me a number of reserved seats. So those are all the seats that are already reserved for that particular date. And if we also know the capacity of the restaurant, we can make a business decision. So if the remaining capacity is too little, we have to return null. So this is the scenario where we have to say, well, sorry, we'd really like to accept your reservation, but we can't because we're sold out, or at least we've sold out of the tables of the size that you need. But if we get past this, though, we can call repository create, and that will create the reservation in the database. And repository create also returns an integer, and we're just going to return that int. So right now, there's no asynchrony anywhere to be seen at all. I'm just going to go through the standard scenario first, and then we'll look at what would it look like to add asynchrony to this. So this is our basic domain model, and if we want to embody that in some sort of type, we could create an interface called maitre d that that defines this method. Now, maitre d is basically just restaurant jargon for the head waiter, and it's a role in typical restaurants that sort of makes decision on making sure that everyone is at the right table and stuff like that. So it's just domain-driven design, if you will. Once we have that, we also need to write the code that actually receives the HTTP request and creates a response. So that's typically something you put in a controller, and in this case we have a method called post that gets called whenever we have an HTTP post against this sort of resource. And we receive that reservation as input, and then we return something called an action result as output. And if you don't know what that is, it's not really important. It's just an interface that models an HTTP response, and you'll see how we return things like that in a moment. Now, if we're doing dependency injection, we typically do it all the way. So we could inject that IMHOD interface that I just showed you, and if I have a dependency on that, I can just call maitre_d.tryAccept, and that returns a nullable int. And then I can do a little check on whether or not that's null, and if it's null, I'll call a helper method. So internal server error is a little helper method, probably on the base class, and it returns one of those action results. So in this case, that just means that the action result represents a 500 internal server error HTTP response. On the other hand, if the try_accept method succeeded, I return 200 OK, so that's another one of those action results. And notice that in the response body, I pull out the integer from that nullable int, so id.value is now safe to access. So in the response body on that 200 OK response is the integer, that reservation ID. And that's the protocol, that's the contract that we have with all the callers of our API, that we need to make sure that that reservation ID remains in the body if the response is a 200 OK response. Now, there's no async stuff going on at all, but if we look at the repository here, we would say, well, okay, really, if we want to implement this is something that talks to a database. Typically, this is just a relational database. And then, you'd say, well, it'd be nice if we could make that access asynchronous, because that might actually improve our performance in various ways. At least it's worth a try. So how do we make stuff like this asynchronous? Well, the way it's done, or you're supposed to do this in C#, is that you have to change the return types. So right now they're just normal objects, and you have to make them tasks instead. All right, so it's not a big change code-wise, but we've now just allowed an implementation detail to leak through into the definition of what the abstraction looks like. Abstractions should be defined by what the caller of the methods need, and that's that try_accept domain model. And it didn't need those things to be asynchronous. That's what's known as the dependency inversion principle. But now we've allowed some implementation detail to leak through into the definition of our interface. And then you'd say, well, okay, is it a big deal? Everyone sort of knows that a repository is really just a database. So you say, well, okay, so it's always going to be some sort of out-of-process resource at least, so isn't that okay? And you can decide to say, well, okay, let's see where this gets us, because maybe that's okay. I can sort of get with that argument. That's fine. So how do we then resolve, are there any problems here? And it turns out that we need to make some changes to try_accept, but they're quite, few. We just have to add async and await, and also we need to change the return type of the try_accept method to a task. But apart from that, this is all the changes that we need to implement, so that's not too bad. But, I changed the type of try except, and that means it's no longer going to compile unless I also change the type of the try except method that the interface defines, because otherwise I'm no longer implementing that interface. So this is where I think I'm beginning to get a little annoyed with this, because I can sort of accept that, well, yeah, okay, a repository is really an out-of-process resource, so it should be asynchronous. But this thing here, this is my domain model, and I see absolutely no compelling reason why my domain model has to be asynchronous, but now it does because of an implementation detail. So now that's, this bothers me. But let's just move on and see if there's more work to do. And there is a little bit more, but we're almost done. Since major data try except is now asynchronous, I also need to add await and async and return a task instead here. But again, very few changes. They're easy to implement those changes, so it's not a big deal. And at this point, we are done. And I'm annoyed about the leaky abstraction, but apart from that, it's not that it's it's not that it's hard work to make these changes. It's fairly easy to do, but as other people have pointed out before me, once you go async, you have to go async all the way. And this is not a talk that tries to drive home that point. It's basically just to say, well, this we know already. There's no other way. And I'm always like, whenever people say something like that, there's no other way, my reaction is typically, oh, really? Because, I just need to come up with one counter example to say, well, yeah, there is another way, and that means that you were wrong. There is another way. And there is. Now, to be clear, I'm going to show you what that other way is, and I'm not here to sell you on that other way. I'm not trying to convince you that the way that I'm going to show you now is better. I believe that sometimes it's better, and I believe sometimes, what I've just shown you is a pragmatic solution that's probably going to be better for you. But I believe in giving you alternatives. So if you don't know about the other way, you wouldn't know that it exists, and that means you don't have a choice. Now, when the talk is over, you know that there's another way, and now you have a choice, and then you can make a decision. So it's just to raise awareness. I'm not trying to sell you on doing one thing or another. But this is where part one ends, because in order to figure out what the other way looks like, we need to learn some other stuff first. So I'm going to put aside the dependency injection and the async await stuff a little bit, and instead talk about a completely unrelated question it would look like, but it turns out that they're actually quite related. So the other question is, how do I get the value out of my monad? And first of all, I'm not expecting you to know what a monad is. I'll go through that, so once we're done here, you also know what a monad is. So this is really going to be, there's a lot of stuff to learn here, and it's super fun and super easy, not to be worried about at all. Now the short answer to this question is mu. Okay, so assuming everyone understands Japanese, right? No. But there's this interpretation of this character and the word mu in Zen Buddhist philosophy. And if you want a Western perspective on that, you can always consider reading Zen and the Art of Motorcycle Maintenance, because it's a good book. Or you could read Gödel Escher Bach. That's maybe a little bit more programmer-oriented. But both of those books talk about this way of sometimes asking or responding to a question. When people are asking a question, you say mu, and basically it means unask the question. So the idea here is that this is a response that basically tells you the question doesn't make any sense. We should now talk about, why you would ask that question, and then, once you've understood that the question doesn't make any sense, you will become enlightened. There's always a lot of enlightenment in Zen Buddhism, I suppose. It's very closely related to another thing that's maybe a little bit more down to earth, the XY problem. Now, the XY problem is something that often happens when you're trying to learn something new, something that you don't know how to do yet, and you're trying to learn it. And it's such a common thing that there's actually a Stack Overflow fact that talks about the XY problem. But basically, it's this thing where you're trying to learn something new, so a new library, a new language, a new way of doing things, and you well, you're struggling with things because it's hard to learn new stuff, and that's completely natural. So we could try to illustrate that by saying you have a goal, you're trying to accomplish the goal Y. And you have either implicitly or explicitly formulated yourself a plan to how to achieve the goal. And you say, well, I'll go through a series of steps, and that will enable me to reach the goal. And one of those steps we'll call X. And then when you try to execute on your plan, it turns out that you're stuck on X. You can't figure out how to do X. And then you go and ask on Stack Overflow. And the friendly people on Stack Overflow will immediately tell you, oh, yeah, that doesn't really make any sense. What is it that you're really trying to do? So if you engage into a conversation like that, someone who really knows what it is that you're trying to learn will understand that it doesn't make sense to try to do X. That's a nonsensical question. But once you figure out, by conversing with an expert, that you're really trying to do Y, that's your goal, the expert will say, oh, if that's what you're trying to do, you should do Z, and Z will enable you to do X, to do Y, sorry. So it's a completely different way of thinking about things, and that happens a lot. And this happens often when monads are involved as well. So we often see lots of very specific questions about specific monads, but I've sort of just tried to generalize the question to this. So how do I get the value out of my monad? Well, you don't. That doesn't make any sense. That question is nonsensical. But I think it's worthwhile to just look at, why would you ask that question? But first, we'll have to figure out what's a monad. Because I'm not assuming that you know this. And it's one of those things where there's a lot of buzz around a word, and lots of people find it intimidating, but it's really not. So if you forget about all the intimidation for a moment and just think, this is just a friendly, practical thing, it is. Then just I'll teach you, and it'll take 15 minutes, and then you'll know what a monad is. So just just go to this with an open mind, and it'll be fine. Now, what's a monad? Okay, a little bit more jargon here. It's a functor you can flatten, and then you go, okay, that's not very helpful. What's a functor? So we'll need that. So I'll go through that. So actually it turns out that what's hard to explain, but not so hard, but just the hardest part of these two things is to explain what a functor is. Once you understand that, a monad is just a practical thing that enables you to work with functors. So let's start there. So a functor is a container. Well, not that kind of container. Also not a dependency injection container. Also not a shipping container. It's just a data structure. It's a container of values. So we could try to illustrate that by just saying, well, it's just sort of, some rectangle, and you can imagine that there's some data inside that. So typically in a language like C#, this would be a generic type. So this would be some sort of container of T, something like that. So one thing we know about it is that it contains values of the generic type T, and it supports what we call a structure-preserving map. And what that means is that you can change whatever is inside the container without actually changing, the outside look and feel of the container, if you will. And that sounds abstract, I know. So let's look at an example. Now, the most intuitive way to think about this is just think about it as a collection. So here's a collection of numbers. What is a structure-preserving map? Well, you can add 1 to each of the numbers, and now you have a new collection of numbers. And since it's a generically typed container, not only do you don't have to translate numbers to numbers, you can translate numbers to strings, or you can translate numbers to Boolean values, or whatever you would like. So this idea of this translation being structure preserving means that it preserves the structure of the input container, whatever it is. And the structure depends a little bit on what type of container we have. So this is just an example. Collections are just one example of this overall abstract concept of a functor. But for collections, the structure is something like the size. So, the input collection here has the size of 6 elements, so all the outputs also have that same size. And there's an order to a collection, and that means the order of all the outputs here is determined by the order of the input collection as well. So that's the structure of typical collections. List of T, arrays, any enumerable of T, stuff like that. Just one example of a functor. Now, another thing we might learn about functors is that the output is still the same type of container. So a collection maps to another collection, and that means you can keep on doing this. So you can say, let's map that to something else. So you can sort of compose those things together. So that's a pretty nice ability to have. So in C#, this looks something like this. So let's create an array of numbers, and then to perform the first structure-preserving map, we call the select method. So most other languages call that structure-preserving map, or maybe fmap, but in C# it's called select for reasons. Now this is the first step. It just corresponds to the first step that I showed you on the diagram, and this is just adding one to each of the numbers. And that produces a new array, or a new IEnumerable at least, and then you can move on and do another select, and that turns all the numbers into strings, and now you have yourself an array of strings. So you know this already. You know, if you've ever done C# programming, you've been doing this for more than 10 years. LINQ has been around for a long time. So you'd say, well, okay, so if that is an example of a functor, and it is, why would anyone ever ask the question, how do I get the value out of my functor? Because it's sort of like, why would you ask something like, how do I get the value out of my collection? That's not a very reasonable question to ask, because we know that there's more than one value, and what's even worse, sometimes there's no value in an array or a list. So it doesn't make sense to ask the question, how do I get the value out of a collection, particularly if that collection is empty? So people don't ask questions just like that. So you'd say, well, why do people ask, how do I get the value out of my monad, if you knew this already? But the problem is that most people actually don't realize that this is a functor. Because if you read the documentation of what a functor, or what select does, it doesn't tell you that it's a functor, even though it is. So I don't know why Microsoft chooses to keep the truth from you, but I know you can handle the truth, so now I'm telling you. All right. So I think the reason why that question keeps coming up is that you've been using and working with LINQ for years, but you don't realize that you're working with functors. So the first time you actually get introduced to the concept of functors and monads is in a different context. And if you're unlucky, maybe that context is what I call a unit container. So the word unit container is just my invention, but I use that to describe a set of very specific functors that have one thing in common, and that is that they contain exactly one value. So they're guaranteed to contain one value. And for those, it makes sense to ask that question. So lazy of t, for example, again, a type that's been around in the .NET library for like 15 years. This is guaranteed to contain a single value of the type t. And that it's always going to contain exactly one value. It's just a lazy computation. So it's already generically typed. Is it a functor then? Well, again, for reasons that I don't understand, it doesn't come with a select method, but we can add one, so we can write an extension method. So we'll say, let's write a method called select that returns a lazy of t result if the input is a lazy of t. And we're just going to need a function that translates t to t result. And the implementation is basically just a one-liner. It's just that line of code. And this preserves the structure of what it means by being a lazy computation. And I'll give you an example here. So imagine that you create a lazy of int. And you'll notice that inside the lazy computation, it'll block the thread for 10 seconds. But even so, this code immediately completes. Because it's a lazy computation, so it's actually not running yet. You have a lazy of int, so it's sort of like a promise to calculate an int at a later time, but not right now. So you can take that select method that we just added, that extension method, and you can call it on X to produce a lazy of string. And this still completes immediately. So that means, whatever you expect from a lazy computation is still true. Not only does this still complete immediately, now if you now force evaluation and say y.value, that's going to block for 10 seconds. And if you do it again, it's going to return immediately because it remembers the result from the first time you forced evaluation. And this is just how you expect lazy of t to behave. So the select method just preserves your expectations. It just stays intuitive, if you will. So that's a structure-preserving map. It preserves the invariance of what it means to be a lazy computation. So all that takes is just an extension method called select. And we can do the same thing for task of t. So the implementation is a little bit different, but it works the same way. So you can say, let's create a task of int. And again, that completes immediately, even though it starts the task on a background thread somewhere. And that means you can take your X and your task of int and call select on that to turn it into a task of string. And again, that's going to complete immediately because select preserves the structure of what it means to be an asynchronous computation. Even more, if you try to await y, then it's going to block until the task is completed. But then again, if you try to do it again, that's going to complete immediately. So again, select doesn't change your expectations. The task of string behaves just like you'd expect a task to behave. It doesn't change anything. So it's a structure-preserving map. So now you've seen a couple of examples of functors. You've seen collections, you've seen lazy of t, you've seen task of t. Those are all functors because they have structure-preserving maps, and in C# we call those select. All right. We can actually do more with this. So far you've seen me use this syntax, but we can also rewrite all the expressions that you've seen so far to query syntax. And this is a syntax most people associate with database queries, but it works on, if x is any enumerable of int, then y is inferred to be any enumerable of string. But it turns out that now we've added those select methods. This also works for lazy of t, and it also works for task of t. So it might be a little bit surprising that this language feature works for your custom types. But the reason why it works is because that language feature is designed around the abstraction of a functor, and if the compiler can see that you have created a functor, then this syntax compiles. So they knew what they were doing when they were creating that sort of syntax, even if you can disagree with the naming conventions they chose. So that's basically a functor. It's some sort of generically typed data container that supports a structure-preserving map. So now we just need to figure out what a monad is. And I would say, just getting your head around that is a very, very abstract, sort of fuzzy concept that a functor is not an interface that you implement. It's just sort of, if your data looks in a particular way, then it's a functor. Now, if you can get that, figuring out what a monad is easy, because that is just solving a practical problem with functors. And basically what I told you is it's a functor you can flatten. So let's just have a look at what does it mean to flatten a functor. We haven't really seen something that doesn't look flat already, so we'll probably have to just briefly go through that. So we'll go back to collections for a little a moment. So here's a string. It's a string of foo, bar, but it's just one string. And there's an instance method on string called split, and that enables you to split on a character. So in this case, we're going to split on the comma, and the result of that is just an array of strings, foo and bar. So that's fine, and you probably knew this already. Now, what if you have a collection of comma-separated strings like this, foo, bar, and bas and cukes? Now, if you want to do a structure-preserving map over those two strings, but you also want to split each of those comma-separated strings, now what's going to happen now is split is going to produce arrays in itself, so now you get a nested array. You get an array of arrays. So that's what I mean by a nested container. Sometimes this is what you want, but sometimes you just want just a flat array instead of this array of arrays. So what you can do instead is you can call a method called selectMany. You probably tried this already. And the reason why it's called selectMany is exactly because it addresses this problem. And it says, well, you're going to select for each of the comma-separated strings, but the operation that I'm going to execute inside that lambda expression, split will produce many values. So for each of the input elements, I'm going to produce many values. So I'm going to select many, and I'm going to flatten as I go, and then I just have a nice flat unnested container. So this is just an array of strings instead of being an array of strings. So that's what I mean by flattening a functor. If you have select many and it's well behaved, then it's a monad. That's basically what makes it a monad. It's just solving that practical problem that sometimes you need to remove levels of nesting from a generically typed container. That's all it is. All right, so would you ever run into that situation with other types of functors? What about task? Well, what if you define a task of int x and another task of int y? And then you say, well, I'd like to add them together, but I'd like to do it in the functor style, so I'll call select, and I'll try to do something like this. Now, if you do this, this compiles, but you'll notice that the output z is a task of an int. Now, how do you get the int out of that task, by the way? Well, you can actually await z. Sort of funny that you can do that, but that actually works pretty well. But it's a little odd, isn't it? So And instead, what you can do is you can add, just like you added a select extension method, you can add a select many extension method, and that means it's just going to flatten as it goes. And now Z is just a normal task of int that you only have to await it once in order to actually get the value out of it. And not only that, with the appropriate select many method, you could also just rewrite everything in query syntax, and it would look like this. So it's because task of int is a monad that this is possible to do. The compiler understands monads as well as functors. So that's another example of a monad. You can just flatten things as you go, and then that's a monad. Now, there are definitely examples where it makes sense to ask the question, how do I get the value out of the data container? For a lazy string, you can get the string out of it by forcing evaluation. Same thing goes for task. You have to await them, but you can then get at the string. And this is not only true for C#. This, you run into the same situation in F#. There's something very similar called async of string. And even in Haskell, you have those unit containers that are guaranteed to contain just one value, and you can access that value by run a function on the container. Not all of them, but a lot of them. This is just the simplest one that exists. So if this is your introduction to functors and monads, and your brain is trying to pattern match on things, and you sort of have forgotten that collections are also functors and monads, maybe you reach that wrong conclusion that you can always get the value out of the monad, because for these containers it's true, but there's lots of other monads, there's lots of other containers where that's not true. And people often run into problems with what I call semi-containers. So unit containers were the ones that were guaranteed to contain exactly one value. Now, so I just named the other ones here semi-containers because they're not guaranteed to contain one value. They may contain a value, but maybe they don't. So on average, if you will, they contain half a value. So semi. Stupid, I know. Anyways. The most famous one in C# is probably nullable of t, and you know nullable of t already. So if you have a nullable int, we looked at that already. That's an ID. Here's a slightly different example. You could make a check on ID and see if it's not null, and if it's not null, you know that it's safe to access id.value. And then you have this customer object here that requires a proper int. So that would be some sort of customer identity, customer ID. And you can only create a customer if you have an int that you can pass to the constructor there. So you can say, well, if that's possible, if it's safe to access id.value, I can create a new customer and I can return that. But whenever you're returning something, you also have to deal with the case where there's nothing there. So what do you write in the else branch here? And I know what lots of people do. They do this. And it is, this should not be allowed according to the Geneva Convention, because it's what you're doing here is you're leaving behind a mine. You're creating a little helper method there that says, well, here's something where the return value is a customer, and then you give that helper method to me, and you say, well, just call this method and you'll have a customer. And I'll say, oh, gee, I'll have a customer, and I'll start calling your method and do things with the customer, and everything compiles and all is fine, and then I put my code into production and everything just explodes. So if you structure your code like this, that's just sort of like creating a minefield. It is really, really hard to navigate code that is structured like this, so please don't. But it's hard if you don't know what else to do. So the question is then, since I'm talking about functors and monads, can they help you? So let's have a look at that. So is nullable of t a functor? Well, it's not. But we can make it a functor by creating an extension method and call it select. But there's one catch, and that is this only compiles if we add those generic type constraints here. T must be a struct, T result must be a struct. And the reason for that is that nullable of t itself is defined, it's only defined for t's where t is a struct. So you can only map between value types. But then it's a functor over all value types, but not over all types in general. But you can, if you want, write something like this where you can say, well, let's start with a nullable of int and then transform that into a nullable of bool, and that works. So that's quite useful. So you'd say, well, okay, so the nice thing about doing those structure-preserving maps with select is that you don't have to check for null. You don't have to check whether the value is there or not. You can just say, well, just compose my isEven method with I.select, and all edge cases are actually being taken care of here. So that's really nice. Can I do something like this with my ID? I had to create that customer before. It'd be really nice if we could do something like this, and that would be safe. So I could say id.select, and then say, if ID is a value, there's an integer inside of it, and then that I in the Lambda expression would be the integer, and then I could create a new customer. That'd be really nice. Yeah, but doesn't compile, sorry. And the reason for that is that, customer is a reference type, and we had that type constraint saying T can only be a value type. So, sorry. That's C#8 may do something about it. C#8 will do lots of things. So let's just pretend that C#8's not happened yet, because it hasn't, and we don't really know exactly how it's going to work out anyway. So, we'll just pretend that. What we can do, though, is that we can say, well, okay, so it'd be nice if nullable of T just lifted that constraint, and until C#8, then we can't really make that happen magically, but we can just make our own functor. So we'll make our own functor, and we'll call it something, and we'll have to come up with a good name, and we'll just think about calling it maybe of T, because that's what everyone else calls it. So I didn't come up with that idea. And there's lots of ways you can implement this, but here I'm just using a flag and a value, and then there's two constructor overloads. So there's one constructor that doesn't take any arguments, and it just sets that hasItem flag to false. And there's another constructor overload that takes an item of the type T as input, and saves it in a class field and sets the flag to true. So this enables you to model a generically typed container that may or may not contain a value. So it's already generically typed. Is it a functor? Well, not surprisingly, it is. We just have to implement the select method. So it doesn't have to be an extension method. This is an instance method on maybe of T, and the output of that should be a maybe of T result. So how do we implement this? Well, it's pretty straightforward. Just ask, is hasItem true or false? If it's true, we know that item is available. We know that item is of the type T. The selector, that function that is being passed in, is a function that can take a value of the type T and turn it into a value of type T result. And we have a value of type T, that's item, so we call selector with item. That produces a value of T result. And then we just package that in a populated maybe of T result. So that works. What do we do in the other case? Do we throw an exception? No, we don't have to. We just return an empty maybe of T result that doesn't contain anything, and that's all good. So again, this is a structure-preserving map, because we are taking populated maybes and translating them to other populated maybes, and we're taking empty maybes and translating them to other empty maybes. So we preserve the structure of whatever the original maybe was. We're not changing things around. And we can do the same thing with the select many, so with this flattening operation, and it just looks a little bit different, but the concept is the same, so I'm just going to skip over this briefly. Now what you can do with the maybe of T is that you can create some nice composable helper functions. So you could write something like try parse int, and then you'd say, well, that's going to return a maybe of int, but why do we need this? We already have int.tryparse in the base class library, so why is this necessary? But this is composable, because what's often the problem when you use, int.tryparse is that you have to check whether it returns true or false. And you normally don't have a problem when the return value is true, because then you have the integer that you were looking for, and all is good. And in this case, we just put that into a maybe of int. But often, then again, you run into this problem. What do I do in the else branch? If I didn't, I looked for an integer and I didn't find one. So what do I do? And this is again where, in many other cases, people would throw exceptions. But no, just return an empty one, and that's going to solve your problem. Now this is safe, and you can do the same thing with parsing dates, and it's exactly the same template here. So if you imagine that you have to write a little application that says, enables you to rent a car. What you can do is you could say, well, the first thing you want to ask a user about is, you have a little method there called collect date, and when you call that, it's going to ask the user, okay, please input the date on which you want to start your rental, and then the user types in a date, and that's a string, and then you pass the string to try parse date, and now you have a maybe a date time. And then you ask the user, okay, so for how many days would you like to rent the car? And the user types in the answer, and that's a string, and then you pass that into a maybe of int. And then you ask some more questions, and once you have asked all the questions you'd like to ask, you can start to compile all or compose all of those values into a maybe of contract. So you can use query syntax and you say from D in MD, so D is now, because of the way query syntax works, D is just a date time value. And you can say from I in MI, and I is just an int. And then finally you can say select contract, and then you could just pass in all of those various different primitive values there. So what you end up with is a maybe of contract that may or may not actually contain a contract, but it's safe. No exceptions will be thrown here. It's either going to be there or it's not going to be there, but it's quite explicit that you have to deal with both cases. So far so good. Now this is fine, but then this is where people start to run into problems, because they say, well, okay, contract is a class and it contains some methods that I'd like to call, because there's, for example, a calculate price method, and I need to call the calculate price method because I want to show a quote to the user and say, this is what that rental is going to cost you. So people start doing stuff like this, where they say, let's declare a decimal called Q for quote, and then we test whether the item is there, and if it's there, we'll try to actually get at the item inside and call calculate price on that. And again, yeah, that doesn't compile. And I very deliberately designed the API for maybe so that this doesn't compile. I hid those has item and item as private fields, because you're not supposed to do this because it's brittle. Again, what's going to happen if that Boolean expression is false? Is that going to leave Q as 0? Do you want to run the risk of accidentally ending up showing a quote to a user with a price of 0? This is what error handling and complicated branching will often lead to. 20 years ago, I was doing e-commerce websites, and there was actually a bug on the site that did exactly that. Because we did something wrong, and instead of actually pulling prices out of the database or whatever, everything was just initialized. And what's the default value of an integer? Well, that's 0. So everything was just free on the web shop. That's not a good problem to have. So, yeah, not a good way to structure your code. What should we do instead? Let's try it again. We know that maybe of t is a functor, so that means it supports a structure-preserving map. So what if instead we just did something like this, where we say, let's just call select on MC, and that means inside of that we'll pass a lambda expression that calls c.calculatePrice. And the output of that is a maybe of decimal, and it's a structure-preserving map. If maybe of contract was populated, then the maybe of decimal is also going to be populated. If it was empty, then the result is going to be empty as well. But it's safe. You don't need to do then any if-else checking. It doesn't throw exceptions. This is always safe to do. So this basically answers the question, how do I get the value out of my monad? Well, you don't. You inject the desired behavior into the monad. And that's basically what we did. I just took that calculate price and said, it's going to happen inside the maybe container. I'm not taking it out of maybe. I'm just putting the behavior inside the container and just transforming the context as I go along, if you will. So this is safe, and that's the way you're supposed to work with monads. And know what you're going to say now. You say, well, yeah, but ultimately I need to produce a result. I need to put, I can't, display a maybe of decimal on the screen. I need to, give the user a price. Yeah, but again, if you don't have a price, you don't want to display 0, then you want to display an error message or something like that, and that's another thing. You don't want to get the value out. You need to figure out how to arrive at a final result. That's not quite the same problem. So let's go back to the collections again and see how do we solve the problem here. Now, sometimes you can just say, well, okay, I have a collection of numbers. Let's just put all the numbers back, on the screen because that's what the user wants. But often it's not. But then the next question is, if you just want to produce one result out of an array like this, is there a ubiquitous single result that you should always produce from an array like this? No. It depends on what you're trying to do. Maybe you want the sum, and you can call a specific method on that calculates the sum, and that's that number there. Maybe you want the average, and I believe there's also a specific method that calculates the average. But maybe you want to do something where there's no built-in method for it. Maybe you want to multiply all the numbers together. So in order to address all the situations where there's no specialized method for it, there's something called aggregate. And I'm using an overload here that takes a seed. So I set the seed to 1, and the reason why I do that is it's not really necessary here, but if the input array is empty, aggregate can't work unless it knows where to start. So if the input was empty, it would just return the seed, and that would be 1. Otherwise, that lambda expression to the right there is going to run pairwise for each of the elements, starting with the seed in the first element. And in this case, I'm just going to multiply all the values together. And the result here is not very interesting because it's 0, because one of the numbers inside of that array is 0. So not so interesting. But the concept of being able to produce a single value, a single aggregate, with a lambda expression and maybe a little seed, we can take that concept and also apply that concept to maybe, and we can make it an instance method, and I'm going to call it match. So this is an instance method on maybe of t that returns a t result. So I'm keeping things flexible here. I'm not saying that we should return, even though this is a maybe of t, I'm not saying we should return a t. We can, transform as we go, and that keeps things flexible. So basically, it's just using the ternary operator. It's just a one-liner. If has item, if that flag is true, we know that item is available, but item is of the type t. We need to transform it into t result because that's the return value that we need. And we have a function called just, and don't worry about why it's called that. That's just the name that it's called. That's a function from t to t result, so we can just call that on item. And if has item is false, if that flag is false, we don't have anything. But then we have that fallback, nothing value of the type t result, and we can return that. That's sort of like the seed from the aggregate function there. So this enables us to always aggregate or collapse, a maybe value into a single value. So now we can return to the third part of the talk. How do I combine dependency injection with async and await without leaky abstractions? So we sort of left off by saying, well, when you do async, it needs to be async all the way. And then I said, well, but wait, there is an alternative. So let's see what that is. So what I'm going to do now is I'm going to move the impure operations to the boundary of the system, and I'm going to explain what that means. But basically the idea is that you have some interactions with the real world, and they tend to be what we call impure. I'm just going to move those to the boundary of the system, and in object-oriented programming terminology, we would just say that that supports an adapters application architecture. So this is something that's been around for decades and is a well-known, well-respected object-oriented architecture. So we should be in good hands here. Now, what's an impure operation? Well, it's basically just something that interacts with an environment. And we have two examples here. So I'm just going to explain what impure is by way of example. So when you call read reservations, you are querying a database. So that's probably what you're doing. And that is basically a non-deterministic operation because you can query a database with, let's say I want all the reservations for this Sunday. And then you query the database, you get some reservations back, and then 10 minutes later you say, I want all the reservations for this Sunday. So the same input argument, but now you get a new result back because the state of the database changed. And we don't consider the state of the database to be part of the function itself. So just viewed from the perspective of the code, that basically looks random. Even though it's not random, it is determined by the state of the database, we still consider that to be non-deterministic. It's things that we'd like to happen, at the boundary of the system and not inside the domain logic. Now, another problem here is repository create. This is problematic for a different reason because it creates a side effect. It creates a record in the database. It changes the state of the database. So everything that has a side effect is also sometimes something that, well, we want this to happen, but we just don't want it to happen deep within our business logic because it makes it difficult to write the appropriate business logic. So we want to move both of those things to the boundary of the system. So let's start with the first one. This is the easiest one to do. We'll look at repository read reservations, and we'll notice that this method is always being invoked. unconditionally. So you could say, well, why should this try accept method even have this responsibility to call repository read reservations? Isn't that just making things more complicated than they have to be? Why shouldn't we just say, well, if you want try accept to do its work, you should tell it how many reservations that are already in the system. And we can do that by just saying, well, instead of calling the method, we just make that a requirement for calling the method, for calling the try accept method, and that we do that by saying, let's promote this to a method argument. So this is a fairly easy change, but well, sometimes things have to get worse before they get better. This is not, this leaves us at a little bit of a bad place because we'll need to go and change the IMHOD interface in order to make everything compile. And then you'd probably say, well, okay, so you made a specific implementation change in the try accept method, and now you have to change the interface as well. At that point, you'd probably say, well, okay, if that's a leak, this is a leaky abstraction if I ever saw one. That's much worse than the other things that I've talked about. So how can you defend that? And I say, well, if I had to stop here, I don't think that I could defend it, but this is just the first in a series of refactorings that I'm going to do. And when I'm done with all the refactorings, things are going to be good. So you're just going to have to trust me for now that this will all end well, even though it doesn't look so good right now. So going back to the post method on the controller, we have already injected the IMHOD dependency. What we can do now is we can just say, let's also take a dependency on the repository, because if we do that, we can just call read reservations here instead of inside the MHOD.try accept method. And then we can pass those reservations to the try accept method, and then all the rest of the code is just the same as before. So this is a fairly easy change to make. I'm just literally just moving a method call to another place in the code, and then I'm done with that. So that wasn't too hard. The other change here is a little bit harder because the problem here is that repository.create is not getting executed unconditionally. There's a branch a little bit further up that returns null, and when that happens, repository.create never gets called. So how do we deal with that problem? Well, if we want to move repository create to the calling site, we sort of have to figure out a way to communicate the decision that we made so that the caller can then act upon that decision. So one way we could do that, we could say, well, we already know how to communicate our decision to the caller because we were returning that nullable int, and we talked about how a proper integer means you have a reservation ID, and that means the reservation was accepted, and null meant that it wasn't. So we could do something like that. But the problem is that the int, potentially, if we have an integer that comes from calling repository create, because that's the return value from calling repository create. So if I move repository create to the call side, I no longer have an integer to return. So instead of having an integer to return, I need something else than an integer. I'd like to return something like nullable of reservation instead, but now I'm running into this type constraint on nullable of t, that t must be a struct. So if instead of using nullable of t, I'd use maybe of t, I can lift that constraint, I can get rid of that. So the first refactoring I'd like to do is to change my nullable of int to a nullable to a maybe of int, because that's going to set me up for making another refactoring afterwards. So if you just keep your eye on the top line of code there where it says nullable int, I'm just going to change that to a maybe of int. And the changes to the code itself are fairly minimal. I'm just, instead of returning null, I'm returning a maybe of int that is empty. And instead of returning the integer directly, I'm going to package that integer that comes from repository create. I'm just going to package that in a populated maybe. So again, I'm going to have to change the IMHOD interface. But apart from that, the post method, I'm still going to call MHOD.try accept. What I have now, though, is a maybe of int. And you saw before that you can't do this check where you say, is it populated or not, and then sort of do an if-else branch here. By design, you're not allowed to do that. But what you can do is you can say, let's call the match method, and if you use named arguments, you can say, well, the first argument needs to be the nothing case, and in that case, we're going to return internal server error. In the just case, we'll need to supply a little function that can turn an integer into an action result. So I'm just going to write a little lambda expression that receives the integer ID and just returns OK of ID. So ID is now guaranteed to be an integer. It is not something that could be not there. It is guaranteed to be there, so it's safe to just do that. And you don't have to do all sorts of defense encoding around this, because that's part of how functors and monads work. Right. Okay, so now we're in the position where we can finally move repository create to the boundary of the system. So I'm basically just going to take it away, but if I do that, I don't have an int to return. So what I'm going to do instead is I'm going to return a maybe of reservation. So either an empty one or one that is just the reservation that I just accepted. And again, I have to change the maitre d' interface, but that's okay. It's going to be okay. And if I do that, I now have a maybe of reservation. And remember that the contract that I have with my HTTP client is that in the case where I return 200 OK, I should return an integer, which is the reservation ID. And right now, I don't have an integer. How do I turn my maybe of reservation into a maybe of int? I call the select method. So I'll just do that, and I'll say, well, I'm just going to take whatever reservation is inside, if there is one, and I'm going to call repository create. And repository create returns an int, so now I have a maybe of int. Well, not quite. I actually have a maybe of a task of an int, because this is asynchronous. But it's okay. Task is a monad, maybe is a monad, and that combination also turns out to be a monad, so all is good. Still. The match method looks a little bit awkward right now. We'll fix it up and make it prettier later on. But it's because we have this combination of maybe and task. It looks a little bit odd with the task from result and stuff like that. But don't worry about that. That's going to be pretty as well. But we have a compiler warning now. If we go back to try accept, it says, this async method lacks await operators. And yeah, it does. It says async, but there's no await, because I very deliberately tried to get rid of those, and I actually succeeded now. So yes, bang, just away with that. No reason to make this asynchronous. This was what bothered me originally, and now I've solved my problem. Maitre d' now looks like this. It still looks leaky. We're still going to solve that problem. But the only change we have to make to the post method is that maitre d.try accept used to be asynchronous. It's not anymore, so we'll just remove the await keyword there. I'll just do it one more time if you weren't paying attention. It says await there. Now it doesn't say await. That's the only change. Cool. One more thing we can do. It just gets better and better. Once you sort of crack the nut, you can just keep improving these things. Because now we go back to the maitre d object here again, and we say, well, gee, that repository dependency, it's not being used. Away with that. That just simplifies things as well. So what we have now is pretty much close to what we could call a pure function. Well, it's in quotes because there's a state mutation happening on the penultimate line there. It says is accepted, sets that's true. So we could address that concern if we're concerned with that. But the major point here is that this is now entirely deterministic. The way that this code is going to execute only depends on the input arguments and nothing else. There are no other dependencies involved that will influence how this code executes. And that means it's completely deterministic. We can control exactly what happens just by making sure that it gets the appropriate input values. So if we go back and look at the post method, we'd say, well, why do we have that IMHOD dependency there? And some of you may say, well, it's really there because we need to be able to unit test the controller. And then, with unit testing, we can create a test double, a mock or a stop. And then we can control how maitre d depends. But then I say, well, yeah, but, with the maitre d, the way that I've implemented that now, you can control how it behaves. You just have to make sure that it receives the appropriate input values. So this is just as deterministic as hiding it behind a mock or a stop. So if you make that change, you've removed the IMHOD dependency. And if you do this consistently, you don't lead the interface anymore, so you can just get rid of it. So that's why, in the end, it doesn't matter, because that's now gone. Now, I'm running out of time, so I'm just going to wrap up here. This still looks a little bit odd, but we can make it prettier. And if you're interested in exactly how you get from that previous example to this. I have a blog post, and a lot of all the source code is on GitHub, so you can sort of read through this. But you'll notice that we start out by calling repository.read reservations, and then we go select many, and stuff like that. So since we can call select many, there must be a monad somewhere. And which one is that? Well, it's the task of T monad, or the async monad, if you will. So you'll notice that everything that needs to be asynchronous is still asynchronous. Read reservations on the top line or the first line there, that's an asynchronous operation. And I just continue that asynchronous operation by going select on the task of T. And then, I also had a little bit further down, I have, repository create. This is also an asynchronous method, and it needs to be asynchronous, and it is. So that's all fine. And the post method itself is asynchronous because it returns a task of async result, action result. So everything that needs to be asynchronous is asynchronous, but the domain model, I just injected that into the asynchronous context, but it's actually synchronous, but it's just sitting there in the asynchronous context and doesn't know that it's now being part of an asynchronous workflow. It's just doing whatever it's designed to do. So how do we combine async and await without leaky abstractions? Well, you inject the desired behavior into the async monad, or the task of T monad. And this is just a specialization of the answer that we already arrived at with monads. You just inject the desired behavior into the monad. So we should have known this already. So behavior injection, not dependency injection. So if you want to know more, I have articles that run you through all of the code that I've shown you here, and there's a link to GitHub as well with all the code there. And right now, if you're concerned about that I removed that IMHOD interface and say, well, but the implementation is deterministic, I'm currently in the process of publishing articles that talk about that problem as well. So I've written them, but they're not all published yet. So if you follow me on Twitter or if you subscribe to the blog, then you'll get notified when those are available as well. And with that, I'm a little bit over time, and I apologize for that. So I'm not going to take any questions, but I'm going to hang around in the conference, and I'll be happy to talk to you if you have questions for me. But those of you who just want to get out, you're welcome to just run away right now. But thank you for coming. Hi.
Just a beautiful way of how to do functional programming.